Good morning everyone, my name is Prashant and today I have the topic of Kirchhoff voltage law in basic electrical engineering. Kirchhoff voltage law. Kirchhoff voltage law KVL is a fundamental law in electrical engineering and physics that describes the conservation of energy in a closed loop circuit. It states that the sum of voltage drops and voltage rises around a closed loop in a circuit is zero. In other words, the algebraic sum of voltage drops and voltage rises in a closed loop circuit must be equal to 0. KVL is based on the principle of conservation of energy, which states that energy can neither be created or destroyed but only transferred or converted from one form to another. In a closed loop circuit, the energy must be conserved and the sum of the voltage drops and voltage rises must be equal to 0. KVL is an essential tool for analyzing complex circuit as it follows the calculations of voltage across a particular element in a circuit by simply applying the law to the loop that contains the element. It can be used to calculate voltages in circuits with resistors, capacitors, and inductors as well as in more complex circuits with multiple loops. So the statement of Kirchhoff voltage law is as follows. The algebraic sum of all voltages around any closed loop is equal to 0. In other words, the sum of voltage drops and voltage rises in a circuit should be equal to 0. Mathematically, this can be represented as sigma of V is equal to 0. Here, sigma V represents the sum of voltage drops and voltage rises in a closed loop circuit. The voltages in a circuit are represented by polarity, which indicates the direction of current flow. A positive polarity indicates current flow from higher potential to lower potential, while a negative polarity indicates current flow from lower potential to higher potential. While applying KVL to a circuit, the voltage drops are taken with a negative sign, while the voltage rises are taken with a positive sign. The signs are based on polarity of voltage relative to the direction of the loop. So derivation of Kirchhoff voltage law. Consider some arbitrary circuit. Approximate a circuit with lumped elements so that time varying magnetic fields are contained to each component and the field in the region exterior to circuit is negligible. Based on the assumption, the maximal Faraday equation reveals that in the external region delta into E is equal to minus dou B by dou T, that is equal to 0. If each of the component has finite volume, then the exterior region is simply connected and thus the electric field is conservative in that region. Therefore, any loop in circuit, we find that sigma of Vi is equal to minus sigma of integral of E into Di is equal to C. Integral of E into Di is equal to 0. V A to B implies minus integral of E into dl. However, the electric potential and thus voltage can be defined in other ways such as Helmholtz decomposition. Numerical problems on KVL. Find the current flowing through 1 ohm resistance by using Kirchhoff voltage law. So a circuit is given. So for mesh 1, 130 volts minus 0.2 I1 minus 0.2 I2 plus 0.2 I2 equal to 0. So minus 0.4 I1 plus 0.2 I2 is equal to minus 20. So for mesh 2, 1 minus 110 volts plus 0.2 I2 plus 0.2 I2 plus 0.1 I2 minus 0.2 I1 is equal to 0. So 0.2 I1 minus 1.4 I2 is equal to minus 110. So by solving equations 1 and 2, we get I1 is equal to 96.1538 amps and I2 is equal to 96.3076 amps. So the current flowing through 1 ohm resistor is 92.3076 amps. So by using Kirchhoff voltage law, find the current flowing through 5 ohm resistor. So in loop 1, minus 2 volts minus 2 plus 0.1 I1 plus 10 I1 plus 5 I1 minus 5 I2 is equal to 0. So minus 15.1 I1 plus 5 I2 is equal to 2. Let that be equation 1 for mesh 2. So 4 volts minus 5 I2 minus 5 minus 20 I2 minus 0.2 I2 plus 5 I1 is equal to 0. So 5 I1 plus minus 25.2 minus I2 is equal to 4. Let that be equation 2. So solving 1 and 2 we get I1 is equal to 0.0855 amps. I2 is equal to minus 0.1415 amps since it is taken in a clockwise direction. So the current flowing through 5 ohm resistor is I1 minus I2, that is equal to 0.2276 amps clockwise. So by using Kirchhoff voltage law, find the current flowing through all resistances. So in loop 1, plus 12.5 volts minus I1 minus I2 minus 3 I1 plus 3 I2 equal to 0. So minus 6 I1 plus 3 I2 is equal to minus 12.5. Let that be equation 1. So for mesh 2, minus 2.5 I2 minus 3 I2 minus 3 I2 plus 3 I1 is equal to 0. So 3 I1 minus 8.5 I2 is equal to 0. Let that be equation 2. So solving equations 1 and 2, we get I1 is equal to 2.5297 amps and I2 is equal to 0.8928 amps. Therefore, the current flowing through 1 ohm resistor is I1, that is equal to 2.5297 amps. Therefore, the current flowing through 2 ohms resistor is 0.2 ohm resistor is 2.5297 amps. The current flowing through 2.5 ohms resistor is 0.8928 amps, and the current flowing through 3 ohm resistor is 0.8928 amps. But the current flowing through 3 ohm resistor in the middle is I1 minus I2, that is equal to 1.6369 amps. So by using Kirchhoff voltage law, find the current flowing through a watt ohm resistor. So in loop 1, 8 minus 2 I1 minus 2 I1 plus 2 I2 minus 6 is equal to 0. Therefore minus 4 I1 plus 2 I2 is equal to minus 2. Let that be equation 1 for mesh 2. So 10 volts. So 10 volts minus 6 plus 2 I2 plus I2 minus 2 I1 is equal to 0. So therefore 2 I1 minus 3 I2 is equal to 4. Therefore I1 is equal to minus 0.25 amps and I2 is equal to minus 1.5 amps. Therefore the current flowing through 2 ohm resistor is I1 minus I2, that is equal to 1.25 amps. So fifth problem, by using Kirchhoff voltage law, KVL mesh analysis, find the current flowing through 4 ohm resistor. So in loop 1, 12 minus 2 I1 minus 12 I1 minus I1 plus 12 I2 plus I3 is equal to 0. So 15 I1 plus 12 I2 plus I3 is equal to minus 12. So for mesh 2, so 10 minus 3 I2 minus 12 I2 minus 2 I2 plus 12 I1 plus 3 I3 is equal to 0. So 12I1 minus 17I2 plus 3I3 is equal to 10. So for mesh 3, minus 24 plus I3 plus 3 plus 3I3 plus 4I3 is equal to 0. So I1 plus 3I2 minus 8I3 is equal to minus 24. So by solving equations 1, 2 and 3, we get I1 is equal to 2.7198 amps, I2 is equal to 2.0572 amps, I3 is equal to 4.1114 amps. So therefore the current flowing through 4 ohm resistor is 4.1114 amps. So in conclusion, Kirchhoff voltage law KVL is a fundamental principle in electrical circuit analysis that states that the sum of all voltages around the circuits and multiple loops and resistors, we can determine the voltage and current in each part of the circuit. Solving numerical problems using KVL is an important skill for anyone studying electrical circuits, and it can improve our problem solving abilities in related fields. Through practice and application, you can develop a deeper understanding of KVL and its applications in electrical engineering. Thank you.